Good afternoon and shut up. So, welcome to the Computer Science Colloquium. Next week, if you're interested in driverless cars, autonomous vehicles, and so forth, Professor from San Luis Obispo will come in and update you on everything that's going on in autonomous cars. Today I have the pleasure of introducing Eric Paulos from UC Berkeley, and he promised me that he will explain how to make your objects obedient. So let's welcome our speaker.
Wow, thank everyone for coming out today. What a beautiful day. I just made the really rigorous commute from Berkeley, but I'm here. It's awesome. So I'm faculty at UC Berkeley in computer science. I'm also part of this Berkeley Center for New Media, and I'm going to talk to you about the work that my students and I have done and try to tell you a little bit of a story around computer science, technology, art, and design. And we'll see how well I connect those, basically. I want to tell you about I'm interested in this sort of hybrid ecology space. And I call hybrid out as, I love this quote by Marshall McLuhan, this idea of the hybrid or the meeting of two media is a moment of truth and revelation from which new form is born. And that really resonates with the idea of working with multiple disciplines, multiple materials, multiple kinds of methods. I also want to talk about design, and I want to use this quote by Herb Simon, who says, "Everyone designs who devises courses of action aimed at changing existing situations into preferred ones." So I like using this because often people say, well, I'm not really a designer. I'm pretty sure all of you chose your clothing this morning. You maybe cooked breakfast. These are all design choices. You maybe don't think of them as formal design, but you design the kind of experiences around you. And I'll add one more quote here that I came across. And I was reading this book, and it said, "Imagine something never done before, by a method never before used, whose outcome is unforeseen." And I think, hopefully for a lot of you, this is what at least many of you, I don't know if the audience is all sort of computer scientists or engineers, but it's very much something that we do. We look at things that we haven't been done and try to figure out how to do them and be inventive. What I found compelling is that really this is a quote from Alan Capra, who is a well-known artist that basically established the whole idea of happenings and really started to think about public space art and new kinds of interventions. And this parallel between art and engineering is always sort of something that I'm aware of. So I'm going to give you the cheat sheet of at least how we do research and the projects in my own group. We basically try to identify some core metaphor in a field, what's happening. We recognize what the metaphors exclude or marginalize, either some community, some kind of interaction, some kind of affordance. We invert the metaphor to bring the marginalized to the center, and then we build some alternative. And so I'm going to go way back for a minute to give you some background. In my thesis work a very long time ago, I had a lot more hair then. That's the other thing you should know. We're looking at sort of telepresence. And at the time, these were very high cost. It needed sort of highly trained operators to use these tools. And most of the tasks were around remote repair and inspection. And the thinking was, what if we inverted that? What if we said it was low cost? What if it didn't require training? And what if the application was just hanging out? And so along with my advisor at the time, John Canny, we developed these remote control sort of personal roving presence devices, so little blimps that floated around, and these internet devices that you may recognize because many of them are around these days in terms of different technologies you can buy. So at the time, we made these devices. The web was very novel, and we allowed people to kind of have this experience of having a remote physical presence. And it was a lot about designing the physical embodiment of that. And we put them in different places. Sometimes it was scary. Sometimes it did supernatural things, like flying very high. And someone recently mailed me this picture because you'll probably recognize the devices at the bottom, but the things at the top were really where it all started, some of the early work that myself and my advisor were doing at the time. Even I pulled some pictures from my thesis. This was us thinking about, well, maybe you'll use this for repair and inspection. Maybe we actually went on Telegraph Avenue and sort of took our tarot card readings from people. Maybe there'll be some kind of a experience you could use a tablet, and this is sort of similar marketing material from Double Robotics. So I thought, hey, I have a lot of failures in my career, so I don't want you to think that everything kind of turns out in this beautiful story about how you have this idea and it turns out to be something larger. But I thought, where did this idea come from? And as much as it came from robotics and my interest there, it also came from artists. And again, Andy Warhol had done this piece, Silver Clouds, around physical emotion and the embodiment of these kind of floating blimps, so to speak. It also came from artists such as Kit Galloway and Sherry Rabinowitz, which allowed people in New York to look into, across a live video link, into Los Angeles, a street. Yes, we can all do this now with FaceTime and Skype, but this was extremely novel in 1980, and people were mesmerized that you could actually do this. So let me give you another example of a project that I found this connection. So I also worked at Intel Research for a number of years, and there I led this group called Urban Atmospheres, and we're looking at how to essentially look at public urban spaces and deconstruct the kinds of activities that happened there and look for opportunities for technology to emerge at large. And we did a lot of different projects. Some of them are things you might expect, mobile phones. I bet this is like older technology mobile phones. But we also looked at park benches and trash cans and street signs and building surfaces and lots of different things. And one of those was looking at this concept of familiar strangers. So familiar strangers is a real social concept. These are familiar people to you. You all have them, but they're strangers. You actually don't interact with them formally. It's actually a real relationship. It's a relationship in which you both mutually agree to ignore each other. Otherwise, it's usually a hostile interaction. So what I mean is, if you ignore your friend, you're actually probably mad at them. But familiar strangers, there's just so much urban density that you can't interact with them all. It's the guy that's always walking his dog on your street. It's the woman on the bus with the newspaper. It's the kid that has the skateboard. These people that are familiar to you that make up kind of your urban life. But we looked at how people could actually experience that using some ways to cue that off of Bluetooth mobile addresses, and we embedded that into some mobile technology at the time. And this is another project that turned out really successfully, and it influenced things like Foursquare and Dodgeball, these sort of social media tools at the time. And I thought, well, where did this project come from? Because, again, this one seems to have turned out quite well. And I thought, well, this also was inspired not only by Stanley Milgram. So this is the same Stanley Milgram that did the obedience to authority experiments. This is the kind of shock experiments. But he also did experiments on the familiar stranger, where he looked at train platforms and looked at how people might interact and establish relationships and remember people across time. So we repeated those experiments, but also was inspired by artists. So this was Vito Acconci. This is a well-known artist that you can perform this piece. It's called the following piece. You pick a stranger in public and you follow them until they go into a private place. I will not bail you out of jail if you do this and get arrested, but you can do this performance piece. But it gets into this idea of our interest in strangers. I'll give you one last example, and then I'll tell you some newer kind of projects. But when I was at Intel, I also looked at, we'd done these telepresence projects that I alluded to. We thought, what if you could send messages to people how else do people communicate? So certainly we're familiar with video. People are thinking about maybe you would have picture messages at the time. But it's a lot about observing what's around you. So we went to a farmer's market. We watched how people communicated that was not talking. So gestures, hand cues, simple touching, things like this. So we did a big ethnography of this. And then at the time, I was working with a group that was doing tiny little sensor network kind of motes, they called them, like almost dust motes. But they were really small technology that you could actually have wireless communication, and it had some processing on board. This is way before like the Arduino and other kinds of tools. And we thought, well, what if we embed that into a kind of wrist form factor and allow people to communicate and gesture across it? So at the time, this was the thinking, again, me with crazy Intel logo around, but that you would have a watch and you would tap on this watch and the other person would feel that remote tap, and the other person could also swipe across it and it would send kind of warming, it would sort of warm up the other one. There was a heating element, a Peltier junction, or you could hold on it and it would actually send your heartbeat across a distance. So you'll probably go, we've heard this story before because this is very much the story of real touch, right? But this was 16 years earlier. Now, I'm telling you this because at the time, people said, stop doing this project. This is a stupid project. Nobody wants this thing. This is, just stop, okay? This is a really bad idea. And so there's sort of some vindication that a major company then comes out with this product. So I don't get any, it's not like I'm part of this. I didn't get any sort of money. I'm not part of this. We never filed any patents or anything like that. But the idea is sometimes when you think you're doing something that seems you're getting a lot of sort of pushback, but if you believe in it, I sort of urge you to stick with it sometimes, because sometimes these ideas seem really out of place at the time, and as time moves on, they're really in place. And it got me thinking about other connections of where I saw basically artists exploring a space before technologists, and these connections and parallels. And one of them I thought of was this Aspen movie map. So this was in 1978. Michael Neymark basically said he had some research money, and he was looking at how you could actually explore the city of Aspen, Colorado. And this is, I'm going to tell you now, it was a laser video disc. That's how awesome it was. And it had a touch screen, double awesome. And you would explore the city of Aspen, Colorado. And yeah, this looks a little like something we have now. Again, I get that, there's about a 30-year difference between this art project and this thing, which you're familiar with. It's interesting that this project got an award. It got a Golden Fleece Award. Anyone know what a Golden Fleece Award is? So this is an award that is given out by Congress for the most egregious waste of taxpayer money. So someone stood up in Congress and said, stop this project. This is stupid. This is dumb. It's a waste of money. Stop it immediately. And here's something else. Okay? I'm not trying to say that if Michael had never done this, we would have never had Street View, but I'm saying that sometimes the lens is not calibrated and there's the wrong kind of feedback. Even the setup, modulo the year of the car, looks the same. Right? So a couple more that I thought that are kind of inspiring, and I think this speaks to looking outside your immediate discipline, is this. Myron Kruger did this project called Video Place, 1974. Probably many of you were not born yet, but this is full body interaction with computer graphics, which probably seems like Microsoft Kinect or Sony iToy, but this was an art piece, and it blew people away. And it wasn't really considered, something that anyone would use, like that's not real computer science. Thank you for showing this, Myron. It's kind of clever, good hack, right? But in fact, it's literally the same kind of gestural interaction. A colleague of mine at Berkeley, Ken Goldberg, did a project called the Telegarden, which is an art piece that lets you kind of robotically come in and control and plant different things in a real garden. And then, of course, we have Farmville. I should actually update this because there's actually lots of real gardens you can remotely control. They're just all around planting cannabis and things. So. But I'll give you a last one, which is Twitter. And I know all of you know Twitter, but Twitter started as an art piece. It actually came out of a project at the Democratic National Convention in 2004 called Text Mob, where they said we need a lightweight way to communicate at this convention because there's going to be a lot of kind of protests and things, and they developed this tool. The convention ended, and these technical people said, well, now what do we do? And they got a job at this other company, which was not named Twitter yet, but basically became Twitter. So lots of things around you are getting inspiration from outside of the sort of restricted domain. And I sort of speak to this idea of two disciplines. And there's a lot of writing about this, but I particularly like C.P. Snow, who writes about this idea of the two cultures, this kind of humanities and the sciences. And he says the clashing point of two subjects, of two disciplines, of two cultures, of two galaxies ought to produce creative chances. And hopefully many of you draw on multiple kinds of inspirations and disciplines for that. We've seen that happen, right? There's I'm not going to go through and elucidate all the examples. I think many things that were successful about Apple were really this combination of sort of engineering and art coming together, and it's spoken about in that way. So, not sure how many people know Mark Weiser. So Mark Weiser is a computer scientist. He passed away in 1999 from cancer, unfortunately, but he was the director of the computer science lab at Xerox PARC. And this is a really well-known, famous research lab. It's where a lot of inventive interfaces came from. It's why you kind of have things like desktop computers that have a lot of the metaphors you're used to. He also coined the term ubiquitous computing. He said, okay, ubiquitous, we're going to have computing every place. And that's very much what we have now. He also said, you know, computing is going to be really different in the future. And this was him talking in the mid-'80s. He said, we're going to have 3 types of computing. We're going to have tabs. Here's a tab, in case you didn't know that you were carrying a tab. This is his version of a tab. We're going to have pads. Okay, I don't think I can tell you what the pads are now, but this is the version of the pads in 1991. And we're going to have boards. Okay, the boards hasn't totally fleshed out. I don't know how many people are interacting with boards, but there's still larger surface interactions. And they invited him to give this keynote talk and to say, what are you talking about, Mark? We don't understand this vision that you're talking about. And he said, okay, here. And I found his keynote talk, and I'm going to share with you one of his slides from 1994. And he says, you know how this is going to happen? He says, you've got to start from the arts and humanities. Okay? This is the leading computer science sort of visionary person coming from Xerox PARC that gave us Ethernet, that gave us metaphors around desktop computing, early interfaces. He said this is the most important part of the talk. So he's coming at this and saying we really need this hybrid thinking around technologies. So what problems should we work on as computer scientists now? And there's certainly a lot of important work, fundamental foundational work around graphics and rendering and networking, theory. These are all extremely important, but sometimes there's a lot of problems that those skills apply to larger societal level problems. Hunger, famine, education, global warming, poverty. These are like really big problems. These are what they call wicked problems. So wicked problems is a real way of framing these. It's actually Horace Riddle came up with this framing, and they're these societal level problems, much like the ones I described. And they don't lend themselves towards a traditional engineering approach. You can't just say, oh, I know the algorithm for solving poverty. Okay, first you start, and then it doesn't work like that. There are solutions, but they often get intermixed and create other side issues or problems. Now, one thing that at least we like to do is sometimes use design thinking to approach these and sort of reason out somewhat plausible, not solutions, but approaches to them. So when I talk about design, often these are the kind of words that come to mind. They're sort of problem solving, things like this. But this idea of more critical design or design research lends itself towards another set of vocabulary. So instead of in the service of industry, what if it's in the service of society? What if instead of designing for production or products, you're designing for debate? Instead of you're thinking of consumers, you're thinking of citizens. So it's a little bit of a different framing. But design research is not about the design object. So you might say, I love the design of this thing, or something else that has a physical industrial design, or a design of an interface. But design research is the process of knowledge production that occurs through the act of design, so as you're producing design. And it actually goes by lots of different names. You some of these may have come across before: critical design, speculative design, critical making. These are all sort of different ways of approaching this, and I'm not going to go through all of them, but I'll give you a very high-level view of at least this idea of critical design and how it functions conceptually. So if you think about here we are today, and here we are moving forward, this is maybe the set of all possible things that could happen, future kinds of interfaces and artifacts. Inside of there is maybe the set of plausible things. It's like probably a little bit more plausible. But what's really probably going to get produced, right? We're probably going to get smaller smartwatches. We're going to get smarter kinds of Internet of Things. These are sort of the very probable things. So what critical design does is says, what if we could pivot out of that and look at these odd preferred objects? These things might actually not even be a good product, things you don't ever want, but they produce a discussion or a debate about technology. So let me just tell you about these 3 themes, and I'll try to go into some specific projects. So a little bit about citizen science, a little bit about new making renaissance, and this fashioning fashionables. So the first one is citizen science. So this is the idea of going out and having citizens almost crowdsource or collect data. And we've done a number of projects in this area Most of them have been using mobile devices and other kinds of sensing technology coupled to, again, networked situations and systems to let you collect, in this case, air quality data. So you could imagine collecting that and crowdsourcing it, creating maps and other things. But I also think it's as much about citizen science as it is about citizen exploration. Because if you think about it, people are like looking down at their devices, but in citizen science, you're encouraged to look up and engage in the world. Not exactly like looking for Pokemon, but some situation, right? So there's actually a threaded connection. So because when you're looking for some Pokemon, you might be going to a place that we need to collect data about the air quality. Is there water here? Is there trash? Is there some kind of, does the path need maintenance? Things like that. So it really promotes wonder, curiosity, and this idea of learning, which I think all of us had when we were kids. Somehow along the way, we got tricked into thinking all of our applications have to be about productivity and efficiency. So like, what happened to the ones that help us be curious and explore? So in that spirit, we've done a wide range of different kinds of experiments and pieces of research. And again, I'm not going to talk about all of them, but they are about the different objects and the sort of physical experiences of collecting the data and thinking about how you share the data. So to give you a little bit more detail, one of them, early one, was to think about how you might attach sensors to municipal vehicles. So the city of San Francisco let us attach air quality sensors onto a lot of city vehicles, and they just drive around the city all day. As great as it is to have people collect data, you and I and others, we kind of sit inside all day. We're kind of sitting here for, whatever, 30, 40 more minutes. But these vehicles are usually moving around the city and collecting data. We also did an experiment looking at how you could visualize indoor air quality. So this was a device that sat in your home, and just like it might say, so-and-so is listening to this music, or they're offline, or what they're doing, this would tell you what your friend's air quality was in their home. So strange things happen. People would go, what's going on over there? Like, oh yeah, I just burned something, right? 2 people ended up quitting smoking, which was not part of the experiment at all, but when they saw it was happening. Largely, we wanted to create systems that didn't create a sense of fear, but let them feel empowered. So you can actually control the air quality in your home by adjusting the way that you open windows and doors and use different appliances and ventilation. And you'll see that a lot of that technology is crept into devices that if you buy any of these kind of Internet of Things systems, they have this inside. There's still problems with the way that they design this, but I won't go into all the details now. We also looked at how people would actually, as communities, tell stories and narratives about these sensors. So we gave sets of sensors to a group of bicyclists, a group of parents, a group of a homeless community, and a group of activists, and looked at how they moved them around. This is the city of Pittsburgh. And you'll notice they don't all sort of want to tell the same thing. They want to do a very different story. Not surprisingly, bicyclists want to put these at intersections where there's a lot of bike traffic. Parents want to put it near parks their children go, and so on. Also, with this project, we knew this was going to happen, but things that sit out in public that do not look like a mobile phone left behind are assumed to be a bomb. So a lot of our projects were confiscated. Police call. We put lots of information. Please call us. We know you're going to call us, so call and say hi. We know you're curious what this is. We also looked at really unusual ways you might think about designing this experience. This was a shirt that you could wear that would actually change based on the air quality around you. So you could imagine walking into your friend's house or a cafe and suddenly, what's going on? You are the sensor. It's very different than the experience. It's this personal thing. We looked at giving out sensors. So these are literally balloons that are glowing based on different particle counts, ozone, different kinds of properties of the air quality. So you would be walking across campus, you'd say, what's going on? Are you guys giving out free balloons? Here's a sensor. Like, oh, where do I want to put this? People now, I'll bring it home, I want to tie it to this post, I want to put it someplace. So we looked, the final version of that, there's a number of other projects, but one of them was to really think about the real problem with air quality is measuring the particle counts that are in the air. And the devices are really high cost. This is a $4,000 MET1 particle counter. It's a Dialos, which is about $300, and I was convinced we can engineer something that would be really low cost. So a student of mine, Rundong Tian, basically brought this down to under $50 in a kind of wristwatch form factor. I agree, it looks ugly, okay, I get it, all right? But it's the right scale and form factor to actually measure air quality. So now you can think of very different experiences of how this might work. You can actually attach it as Bluetooth, of course, so it connects to your phone. So now you can think about, yes, maybe there's something a little bit, another couple iterations, you could actually get it down to scale. More importantly, you should say, but how well does it perform? So this is it performing against that $4,000 Met one that I told you. So we're almost right on. R squared is at 961. So it performs very well against a high cost particle counter. And it lets us put this into different form factors. Now it could be a carabiner. Now it can be something that clips on. Now we can put it into toys. We started to think about how maybe many of you, your first time using a computer, maybe it was something you came across at a home or a friend's house or a library. But what if you think this next generation, maybe they use an iPad, you see kids kind of using these things, or an iPhone or some kind of mobile device. But what if your first encounter was really somehow embedded in these everyday toys? And so we created these sort of Explorer series. There was an Air Explorer, so it was just a plane. It worked just like a plane. You could fly it around, but it also collected air quality data, and it had some kind of vibrated in response. Similar with water, so you could sense what's the difference between your pool and a gutter and the sort of bathtub, and then also water is like a soil sensor. So we thought, how would children get involved with and be encouraged to think about play in this way? All right, let me talk next about this new making renaissance. So how many of you have kind of used like laser cutter or 3D printer, these kinds of technologies? Okay, a little bit. So obviously this idea of really empowering other people to create really new physical devices. And so Obama talks about it as the maker movement is a revolution that can help us create new jobs and industries for decades to come and create new industries that we can't even imagine yet. And you've probably seen this if you go to any maker fair or any kind of sort of place online. You see lots of things people are physically making. So I direct this place called the Citrus Invention Lab at UC Berkeley. People do not normally move this fast, but this is what it sort of looks like. So it's a place for more of a community of coming together. You can think of it as a maker space, but we also teach classes there and do other things. And then I also teach classes around critical making and sort of how people will physically make devices. So remember, this class, it's maybe the assignment, it's maybe a 3-week assignment or so. So these are not really fleshed out ideas, but I'll give you a hint of some of the things students have done. There's obviously a design prompt and different constraints, but so this was a spice printer. So this was like, imagine you're cooking and you go, I want that spice, and it would go, oh, I know that spice, and it dumps out the right amount of spice for your secret ingredient. Some of them are less digital. This was actually a group that was with some architects that figured out they could actually grow moss into a QR code. So you can imagine spraying moss graffiti, I guess, on a building, and then this would sort of grow out. This is a similar kind of more air quality sensing platform. Some are very poetic. This was actually a spoken word poetry boombox. So it's thinking about how would people experience sort of new ideas of spoken word poetry. This is clothing. So this is a dress that actually detects when people are near you, and it says kind of move, give me some space, kind of give me some space. So it's about a personal space around you and sort of moving and pushing back on that. All right, so this is a device that kind of, you can see it's sort of a scarf, but it sort of, you can feel warmth, and it illuminates when you're near places that there's been some kind of sexual harassment or some kind of issue around sexual harassment. Some are quasi-legal. This is a student that actually made a device that watches, I don't know how it is here in Sonoma, but in Berkeley, the meter maid comes with a little flashing light down the street. So this detects the flashing light and then drops a coin in, just in time. Yeah, real problem solving. So we were really fortunate. A little over a year ago, we got a new building on campus. This is it. It's the Jacobs Institute for Design Innovation. So through philanthropic money, mainly Paul Jacobs, he's the CEO of Qualcomm, so a very heavy engineering company. He said, I want a space to bring together art and engineering. And he said it in that order. And so this is a space very much built after that invention lab spirit around hands-on courses, making, building, fabricating, ideation, rapid prototyping, user-centered design. It's a 24,000 square foot building, please come visit us if you're at all coming towards Berkeley. But the classrooms are very different. We have a lot of physical materials, and we're really flexible. We can reconfigure the space. One day I kind of decided to I said, everyone bring a stick to class. And I put, you probably can't see, there's a little campfire that I built in the middle. It's not a real campfire. It's sort of, maybe a better picture. You can see it's just some cardboard logs that I built, basically, and had a light there to kind of illuminate. So we just projected on the ceiling, we laid around, and we roasted marshmallows, and we reviewed some papers, basically, we're talking about. So that was class. But always rethinking what the classroom could be, rethinking how we should expect what kinds of ways we would interact with other students or technologies. So a lot of these projects, and at least if you're familiar with 3D printing, are often what they call digital fabrication. You give a file to some printer and it builds up in layers. And it's usually about modeling the external design, the physical outside side. And this was a project that a student of mine, Cesar Torres, did that said, well, what if you could actually design the inside to change the center of mass, to change the kind of physical properties, to change the compliance in various directions. So now it's not just what it looks like, but what it feels like. And that's why it's called the sort of haptic print. How do you get the haptics involved? Sometimes it's working with different materials. This is a project by Joanne Lowe. I don't know how many, who's played with Shrinky Dinks before? It's kind of a little bit generational because they took it off the market. But Shrinky Dinks is actually pre-stretched polystyrene. And when you heat it up, it shrinks and it becomes rigid. So it means that you can sketch on this material very much like paper, but then you could heat it up and it can form circuitry. So this is a project called Shrinky Circuits, where you could actually sketch and draw circuits, drop components in, you'd heat it up, and suddenly it became a solid object that had, usually when you think about circuits, it's design the circuit and then put it in some box. We don't want to see the circuit because that's the ugly part. We want to put this nice design around it. But what if you think about the actual form as the circuit? So also in this world of digital fabrication, we can do things with multi-material. So you probably have seen people using different plastics or other kinds of material, but you can now embed electronics in line. And so you can actually think about fully printing a drone, for example. So you could print, these are less exciting. These are printed buttons with lights, but you can imagine one pass, you can print this whole thing without sort of doing the electronics and the physical form in one. All right, let me tell you about the last kind of theme, which is this idea of fashioning fashionables. And the idea is to think about really the new kinds of sets of wearable technologies that we might have. So we're certainly familiar with, we have smartphones, maybe some of you have a smartwatch, there's Fitbits. This is the sort of slightly emerging ecosystem. We've seen a little bit of, there was Google Glass, these kinds of things. But what other kinds of ways might we have wearable technology? So one place that we've been looking a little bit at is the fingernail. So what can you do with your fingernail? What kinds of things? Well, the first thing is you think, well, let's put some electronics there, let's put some sensing. This is going to be great. We can use a touch sensor and all kinds of gestures, and you can do a little bit of that. The problem is you then have to either swap the batteries on your fingernails, maybe not so good, charge your fingernails. I'm charging. You get me a coffee, I'm charging, right? It's not going to really work. So we thought, just as a design constraint, what if we said no batteries? What could you do with no batteries with the fingernail? So one of the early concepts is this idea of this alternative fingernail, the alternail, which uses inductive charging and e-ink to basically interact with the physical design of nails. So right now you think about when you paint or color, put designs on your nails, they're basically, that's kind of how it is for the day. But what if it changed throughout the day or as you interacted with things? If it had different kind of physical forms of, so there's a little, this example is maybe less compelling, but it has little dots on it, and you can imagine how you might interact with things. So let me just give you a little bit of background. It has embedded in it a little tiny microcontroller, has an accelerometer. It actually can turn on very quickly just when you touch something. It only needs to turn on for literally microseconds to fully charge up, come up to power, do some kind of a reading, change the display. And for those of you who maybe don't remember, e-ink is bistable, so it'll actually stay on for all the time. Like you don't have to repower it. The power is just to change it. So this is kind of a little bit of how the kind of technology works. So you do have to touch something, but you know, every time you took a cookie from the cookie jar, boom, now it's counting how many times I put the cookie jar. You know, you might touch a tool and it'll tell you if the blade needs to be sharpened, or it might tell you something about, you know, your sort of skills for that, or some kind of information. You could also imagine, you know, maybe you're going to the Giants game. I heard they're in the playoffs, which hopefully it's cool. And you go into the stadium, as you touch the turnstile, boom, says like, you know, go Giants on your fingers. And you get that, like, I went to the game, see? Because you didn't go. You didn't get the cool thing that I got. Or you can also, lots of phones have NFC, this near field communication. So as you touch your phone, you could also have information. Other kinds of wearables. So let's look a little bit more at things like, I mentioned, watches, smartwatches, Fitbits. There's things that track, actually monitor kind of your baby and how he or she is sleeping. There's rings that can kind of post a different status. And we thought, where else can we think about creating wearables? And so we looked at temporary tattoos. This is a project Joanne did. So this is a grad student worked with me, the same one that did shrinky circuits. And she said, well, maybe we can create electronics on a substrate using sort of the same technique that you use for circuit design with multi-layer, but we can actually compose it using different materials and a different process. So I'll give you, the best is to show you a kind of video of how this sort of works. So this is just her, she's always embarrassed. She's dancing because it's playing in response to the music. But we're using a standard silk screening process, and now your skin is a sensor. So I don't know if you can tell, you can actually play video games just tapping. You can call up things on your phone, call friends by just tapping on these tattoos. So we can do capacitive and resistive sensing. We can also do a strain gauge, so we can actually tell how you're actually flexing or bending. And it depends on if you put this on your neck or on your hand, what might happen. We can do the same thing of sending these kind of secret messages. So I could send little heartbeats to, you know, a partner or a friend, and they would get these and sort of sense them. All right. So what else is sort of wearable? So we've also been thinking about clothing. And we had an opportunity to work a little bit with Google, you know, on a project. They did this project, Jacquard. You might have heard about it because they're actually, one vector of that project is going to be a kind of Levi's. You're going to be able to buy this Levi's jacket that has essentially conductive thread in it. The big problem with designing clothing is often, even the shirt I showed you before, the air quality shirt, is that it doesn't allow you to wash it really, right, because of the electronics. So this was literally to change put threads, and you can send electric signals, so you could actually kind of touch something and it would be another capacitive sensor. So our contribution was to say, well, also because you're sending current through there, it'll actually heat up a little bit. And we know a lot about, from electrical engineering, how to create thermal heaters and things. And so we designed a way to actually change the actual clothing by putting thermochromic dye on top of these wires. So the threads change color in response to this heat, as I mentioned. And what this means is that now you might have your clothing that looks a certain way. So I don't know if you can tell, there's sort of some numbers there, but you could imagine this would change over time. This is slow acting, takes sometimes up to like 30 seconds or a minute. You can tell it's sped up 4 times, but now that little dot pattern on your shirt changes throughout the day. Okay, the stripes that you have, you could change, and it could be in response to some status. It could be something around you wanted information to be shown on it, or it could be something simply fashion related. You know, later today, I'm going to change, and rather than change my clothing, I'm just going to download a new pattern. Right? I should have worn better clothing. I got really boring clothing on for this demo here today. But your clothing will change. All right. The last project I'm going to show is a little different. And it's about energy, and it speaks towards a different framing around energy. And so this idea is, we're all familiar with energy conservation, but one of the things is, usually it's about either a carrot or a stick, right? It's sort of, we're going to reward you for saving, or we're going to sort of give you some punishment, be it monetary or otherwise. And the thinking from a design research standpoint was, what if we actually change the way you think about energy altogether? And that is that you think about it as a material. So something that you would, is actually like a material, much like you would give and exchange objects. What if you did that with energy? So let me give you the kind of thought experiment behind this. So this is my son a couple years ago. Think of someone that's maybe a loved one in your friends or family that is on a swing. And what if you collected a little bit of the energy from that? Just a little bit, okay? They brought it home and they gave it to you. Hey, I brought home some energy. Here, this is for you. And then you used it to read a book that night, for example. So is that different than just plugging into the wall? So my claim would be, yeah, that's a lot different. It's handmade. It's from a friend. It's a loved one. There was actually, I can imagine them playing and doing something that was, on this swing. But that feels very weird. We don't think of energy that way. We don't often think of the kind of, fresh energy or local energy, or things like in that same vein. Usually the discussion, as I mentioned, is about how we reduce consumption. But I would claim, what if we thought about other ways to share data or keep it or store it? You're well aware that people have solar panels, maybe even many of you at your homes or at the dorms here or your houses, where you collect this and you kind of give it back to the grid. But what if it was more about, I want to give it back to just other students at Sonoma State, or I just want to give it to people that are bicyclists, or I want to give it to people that are voting for Hillary Clinton, or whatever your kind of issue was. You want to sort of do something different. The same way you go in, you go, take a penny, leave a penny. What if you're getting off the bus, you're like, yeah, I'll leave a couple joules of energy behind for my bus mates. So if you think about it, we don't really get that kind of metadata with energy now. Our phones and other devices don't tell us about the mix and makeup of this kind of energy, but it certainly could. So we built some devices that are kind of these energy mementos. And this is, again, this was not a sort of fundamental big research project. We did publish papers on it, but it became more of a critical design piece, thinking about, imagine you and your grandfather, turning some hand crank. Here's the energy. Would you put that on the desk and go, wow, that's like energy from my grandfather and I? And it's an odd concept, but it starts to create a new dialogue around how we might share energy. Now, to be fair, lots of little bits of energy does not an energy crisis solve. It's not the message here. But often, taking a really radical stance, putting a new lens onto what the landscape is, and changing the narrative a little bit can create new kind of discussions. And in that, we also created these energy parasites. So these were explicitly designed, kind of very handcrafted looking objects. They actually work. And what they do is they kind of steal energy from other places. So you could attach it to a bus or a train, and just sort of, it creates drag. You're not getting free energy. You're actually slowing down this from some small amount, but you're actually generating a small amount of energy. And then you could either waste it, you could charge your phone, you could, imagine I'm sending you this text message from the energy from the wind that came through the BART tunnel when I was in San Francisco last time. It's like a strange concept. So we built different variations of this that you could, I mentioned the one that you could put onto a sort of tram or subway. Some actually you could put in a store and it could actually pull off energy off of the handrails of an escalator. You could take it off of a headlight of a car, a public fountain. So you have the fountain, you could sort of imagine taking energy off of this. But in general, this was a way to sort of point out where energy is seeping out. Where are the opportunities to rethink about small little bits of energy? So in the end, I leave these are my sort of 10 strategic tips about hopefully the work that you do in the future. Use constraints. Technology isn't always the answer. And I'm a technologist, but often, as hopefully I showed you, there's other places to look and get inspired. So do that and limit yourself. Don't always just rush into the glory of technology and computing. Have that be the foregrounded story, but often it's others. Question progress. So consider the negative outcomes of your designs for society and progress. What's being lost? Sometimes that's okay, but kind of be upfront about it. Celebrate the noir. And so what I kind of mean by that is explore the unintended usage and possibilities of the technology. So sometimes you can find opportunities in looking for these what seems initially like a darker side, but new things emerge. Misuse technology. So hack it, do things the wrong way. It's okay, if you're not doing it, who else is going to do it? You guys are the ones that are the next generation that's going to be rethinking these things. Be seamful. So what I mean is often you'll see technology doesn't work. You've heard this, oh, the Wi-Fi doesn't work over there. Or that could be an opportunity. right? So just as I pointed out, oh, we can't do without a battery. Well, maybe that gives us an opportunity. And then finally, bend stereotypes. So expand the assumed roles around who's using the technology and who's supposed to be using the technology. So we're given a story, but often who's supposed to be using it. Rethink that stereotype and how you might contribute towards breaking it or reshaping it. Blend disparate contexts. So hopefully you saw in this idea of things like the organic and the inorganic, things that were kind of very rigid and very flexible, and think about how they can come together. And many of you that have skills in different disciplines, that's important. Be tactfully contrarian, so be confident in your alternative viewpoint. Embrace problem making. Sometimes you'll do things that don't solve problems initially, they make problems, but that's okay. And of course, read. So do reading and homework and research. And I'll end there. This is thanking the students that have really done all the work in this. And thank you for letting me come out here. And thanks, George, for inviting me. So thank you. All right. I'm like on the money, I think. Exactly on the time.
For 2 or 3 questions.
Yes. The wearable sensors, has anybody done anything with that for people who have lost sensation in their limbs?
Yes. So people have done that where they create essentially remappings of feelings from areas that maybe have less mappings. And so we are actually doing something with that now. We have, this sounds devious, but it's actually not. It's a microflagellation device, so it actually can kind of have this very subtle tapping, and it can create a very different experience, and we can move it around and we're working with a team, they're called Enable Tech, that's around technology for people with disabilities, and they actually look for exactly what you're talking about. So I'm not the absolute expert in that, but people are definitely trying to exploit that, so it's a really good application. Thanks for bringing that up.
Do you want to say something about disobedient objects?
The disobedient objects, right. So that was in the title because a lot of these objects, it's sort of, I feel like they need to be sort of tamed, or often when I think about we make different objects, interactive objects, and we give them a prescribed usage, and we give them a user manual, and we give them a way they're supposed to be used. And maybe I kind of imagine, what would they do if we didn't tell them that was what they were going to do? This is a little bit of kind of thinking about these inanimate kind of objects. What if they had an animation? So how would they be disobedient, do other things, and how could that be a way we would engage with them or be playful with them? So obviously, a lot of things we do have very specific applications, and we do research papers and measure that, but I would say the projects that are really exciting are the ones that contribute towards a discussion in the academic community, but we exhibit them publicly or as art pieces or as design pieces. So hopefully, how many of you are from computer science here? Is it everybody, or is it okay? How many of you have other outside areas? Yeah, what areas?
Environmental science.
Yeah, okay, so environmental design. What else was there?
Astronomy.
Astronomy, okay. Yeah, cool.
Thanks again.